Okay. Hop-laden viroid levels and distribution in cannabis plant tissue from Tumi Genomics. This is their white paper, and it's about how to collect material to be tested. So, hop-laden viroid, if you're not familiar, is a naked piece of RNA that folds back on itself. That makes it a little more stable. So it's a viroid. That means naked RNA, essentially. It doesn't have a capsid. And so these were taken from a nursery, the samples. The test they're using as a PCR test, a form of PCR test. It's 95% accurate for 7.5 viroid copies per reaction, which is pretty good. 2 is probably the upper limit right now, so 100% is still difficult. So some results. Let's see. Call for okay samples, and so 100%. So what they did is they took samples from the new growth, and they got like 10%. From the old growth, 50%. Upper clone stem, 80%. And then the roots, they always got 100%, so 100% for all of them. And remember, your clones are being taken from the upper clone stem. I feel like this is 4 stories, 4 plants. This one probably had an infection for a very long time, and it's basically just saturated the plant. So this is probably a very crappy looking plant. This one looks like it was probably infected recently. But anyway, different stories. I'm going to say that different clones or different varieties is the word I'm looking for, have different resistance to it, the viroid. So upper clone stem, 61%. So this is an infected plant, so 61% success in showing the viroid. If you take the upper tissue, new growth petioles, so that's a petiole right there, only 36%. So 2/3 is evading you, old growth petiole, so it's at a time to grow. And so 75% success, the roots are 100%. So my thought is really about elimination. So if you're taking the upper meristem, as a number of labs do, you're probably going to be successful in getting a clean plant 39% of the time, according to this. I mean, you're not going to do 100 cuttings in the 39% of them. So it's probably closer to a third, which is not too bad. But if you're taking meristems from plants in the grow, a plant arrives, it could have bugs, it could have viroids, it could have viruses, any number of things. Taking the meristem off that plant is destructive to the plant material you have, and bugs could get into your grow. So I take the policy of initiating plant material and then getting rid of the mother plant a week later, so when you know that it's actually taken in the lab, or it's successful in the lab. So, but that's my opinion after 28 years, 25 of virus elimination. So anyway, virus load, and so here's the level that they're aiming at with qPCR, which is the semi-new version. So anyway, so this is the range. That's the average. This is the 1 standard deviation, I believe. And you can see the old, it's all over the place. Upper stem, still pretty much over the place. But some of it, if you had the far range of this as far as your sample goes, that's not going to show up. And so it is recommended that you test your plants, clean plants, every 6 months to make sure they stay that way. And for the most part, I've been having good luck with that. So, and then the roots are within the range. And then the little diagram about if it's damaged here, the viroid will flow to a sink in the plant, which makes a certain amount of sense. But viroids are not terribly successful in destroying a plant. That's why they linger, and that's why this is a good pathogen, because it evades obvious detection. It doesn't get into your plant and just kill your grow immediately or anything like that. It spreads very slowly, and as normal viruses and viroids, they can infect certain parts of the plant and not all of the plant. So I feel like that's selecting for more effective, I'm going to say more hidden viruses and viroids, so they can elude you. They're not as destructive as a regular one is. So you're pushing the evolution. And this little follow-up study is if they just look at a petiole, they get 33%. If they pool the petioles, they get 100%. So if all you have is vegetative material, pooling it from a variety of spots on the plant gives you better results than that. So you want to know if it's dirty or not. So root material is the best. Upper part, lower part, both work quite well, and I think it's just that this viroid is really evolved for that tissue, which, you know, their viruses as a group tend to infect certain tissue. So more than just all tissue. You can think of the common cold, where do you experience it? In your nose and throat and lungs. So it's not everywhere in your body. So because that's the tissue, because the viruses want to, I'm putting some personality on them, but they want to multiply and then escape and infect more. So things that don't escape aren't terribly successful viruses, or viroids, as the case may be. Like that, a good pathogen infects but doesn't necessarily destroy the host. If it destroys the host, it destroys itself. So it's a delicate balance there. So anyway, hop-latent viroid, and there's a bunch of tissue, or not a bunch of references. You want to you want to test the roots. And my experience has been that if it doesn't root, it probably has the viroid still. So things that have, and you know, if you meristem them and they grow up and they're suddenly producing roots, test that one. The things that are a little so-so, I have plants that are perfectly fine looking, but I know they have hop-latent viroid, and you wouldn't, if you compare them to another variety that's a lot more vigorous, it's obvious. But if you just compare all the cuttings of a particular type, and maybe some of them have the viroid and some of them don't, it's not terribly obvious unless you look at the roots visually in the lab. You can say, oh, those roots are really looking good. These other plants are looking fairly poorly and don't have obvious roots. Guess which ones are infected? So that's a field study of hop-latent viroid. So, and there's some data. So there you go.